If emerald green resembles a bright meadow under sunlight, hunter green is closer to the deep ocean or a pine forest at dusk. These are the darkest shades within the green spectrum and are often mistaken for brown in low light. Their appeal comes from their subtle quality, inviting a closer look to fully notice the green tone. The biological factor behind this shade is density. Research suggests that darker green eyes have a thicker collagen structure within the iris. When the stroma is denser, it does not scatter light as strongly as it does in lighter eyes. Instead, it absorbs more of it. When this denser structure combines with a moderate level of melanin, the result is a color that feels deep and intense. This variation challenges the common belief that light eyes are simply defined by the absence of pigment. In hunter green eyes, there is enough pigment to create depth, but not enough to turn the eye fully brown. It sits at a careful balance point.
Ow!
In clinical observation, people with darker green eyes may experience slightly more protection from ultraviolet glare than those with very pale eyes, because the darker surface absorbs stray light more effectively. The result is a steady, grounded gaze, rather than a brighter, airy one. Now we shift completely to the opposite end of the spectrum. We have discussed darker tones and bold shades, but what about the palest variation of all? That brings us to the mint, or pale green. The mint or pale green eye is often described as the most delicate and striking of all the green variations. Imagine frosted glass with a faint green glow behind it. These eyes can appear almost transparent and are often called icy, though they are clearly different from blue. The science behind this look comes from an extreme lack of pigmentation. In this case, the stroma is very loose and contains very little melanin, along with only a trace amount of yellow lipochrome, because there is so little pigment to absorb incoming light. Most of the light that enters is scattered back outward. It follows the same basic principle that makes clouds appear white, where light reflects in many directions. However, because there is a small hint of yellow pigment present, the scattered light shifts away from white-blue and toward a soft mint green. Observational data suggests that individuals with this eye type may be more sensitive to bright light. This sensitivity, known as photophobia, occurs because their irises allow more light to pass through toward the retina. It becomes a trade-off. The eye color appears rare and almost unreal in its clarity, yet the person may need sunglasses even on a cloudy day. The visual impact of mint eyes is strong because the pale iris creates sharp contrast with the dark pupil. The black center stands out clearly against the light background, forming a focused and intense gaze. Finally, we arrive at the rarest and most visually complex type, the golden or amber green eye. The golden or amber green eye should not be confused with solid amber eyes that appear entirely gold. Instead, this type is a green eye layered with golden tones. Picture a green leaf in late autumn as parts of it begin turning yellow and gold. That is the color range involved here. Its effect happens when lipochrome, the yellow pigment, is deposited in heavy but uneven patterns. Rather than blending evenly with the blue light scatter to form a consistent emerald tone, the yellow pigment sits in visible patches or streaks across the iris. As a result, the eye may look mostly green in shadow, but when sunlight hits it, flashes of gold and copper become noticeable. Evolutionary biology points out that lipochrome is far less stable than melanin. While melanin levels tend to remain consistent, lipochrome distribution can vary widely in both amount and placement. In this eye type, that uneven distribution creates a metallic appearance. It is often compared to the eyes of animals such as wolves or large cats, which is why people frequently describe it as wild or exotic. The combination of a cool green base with warmer golden highlights creates a striking contrast that naturally draws attention. The shifting balance between these tones produces a visual effect that feels energetic and ancient at the same time. Now that we have explored each variation, we can ask a larger question. Why does it matter whether an eye is mint, olive, emerald, or amber green? It matters because the word green is simply a label we use to describe something far more detailed. When you look into someone's eyes, you are not just seeing a color. You are seeing the precise structure of their collagen fibers inside the iris. You are seeing the exact level of melanin shaped by generations of genetic adaptation. The next time you look at yourself in the mirror or meet someone new, pause for a moment. Do not focus only on naming the color. Pay attention to the structure. Notice how light moves across the surface, consider the layers beneath. Every variation tells a story about biology and inheritance. There may even be combinations and patterns we did not cover here. I would like to hear from you in the comments. Which of these 7 types most closely matches your eyes? Or which one do you find most striking? If you enjoyed this exploration into the science behind eye color, pressing the like button truly supports our work. Thank you for watching, and stay curious. The idea of green eyes is actually a huge simplification. It's unlike brown eyes, which get their color from actual brown pigment. Green eyes are not created by a true green pigment at all. They are the result of physics, lighting, and genetics working together. Across the entire human population, true green eyes are extremely rare, appearing in only about 2% of people worldwide. Yet within that small percentage exists an incredible range of variation. We are not talking about a single shade. We are talking about different structural effects inside the eye that produce 7 clearly different visual experiences. By the end of this video, you will see how light interacts with the structure of the iris to create these striking differences. And you may realize that what seems like one simple color is actually a complex optical illusion. Let us begin with a type that is often mislabeled but has a fascinating structure: the aqua or turquoise variant. Think about standing beside a glacial lake. The water is not blue paint, it's clear, but because deep water scatters sunlight, it appears bright blue-green. That is a perfect comparison for the aqua green eye. In iris observation, this is one of the most confusing categories because it sits directly between blue and green. The body does not produce turquoise pigment. Instead, this effect comes from the Tyndall Effect, the same type of light scattering that makes the sky look blue. In these eyes, there is almost no melanin in the front layer of the iris, called the stroma, and the structure is very fine. Short blue wavelengths scatter strongly. A tiny amount of yellow pigment called lipochrome mixes with that scattered blue light, and together they appear aqua. If the fibers were thicker, the eye would look gray. If there were more yellow pigment, it would look fully green. The shifting appearance is not magic. It is simply light scattering, reacting to the surrounding environment. Now let's move toward a warmer and more grounded shade. One that has played an important role in genetic research, the olive green eye. If the aqua eye resembles a bright glacial lake, the olive eye is closer to aged bronze or a forest floor under sunlight. This variation stands out because it challenges the belief that green eyes must always appear light. Olive green eyes carry a deeper, darker tone. They do not have the bright, translucent quality seen in lighter greens. Instead, they show a softer, matte appearance that interacts with light in a different way. Biologically, this comes from having a moderate amount of melanin. The same light scattering still forms the green base, but it is layered beneath a stronger presence of natural brown melanin. You can think of it like viewing a green light through tinted glasses. The brightness is reduced, and the color feels richer and more layered. The result often resembles moss resting on stone. This combination creates a calm and inviting appearance that many people describe as warm or trustworthy. That perception may come from the way olive eyes sit between very light eyes and very dark eyes. They hold some brightness but also depth. From these earthy tones, we shift to a type that is widely recognized, yet often misunderstood: the true emerald. This is the vivid, bold green often seen in magazines. Unlike olive or aqua shades, emerald eyes tend to stay consistently bright regardless of lighting conditions. Their stability and clarity make them stand out immediately. This emerald shade is often considered the most iconic form of green eyes. It appears bold, solid, and clearly defined. Unlike aqua or olive tones, emerald eyes do not seem to shift much depending on lighting. They remain a strong grassy green in almost any setting. To understand how this happens, imagine how a prism works. In emerald eyes, the stroma, the fibrous layer of the iris, is clear enough to scatter light and create a blue base. However, unlike lighter blue-green eyes, emerald eyes contain a much higher amount of yellow lipochrome pigment. The result follows a simple principle similar to mixing colors in art. Strong blue scatter combined with strong yellow pigment produces a vivid, unmistakable green. Observations in iridology suggest that the glow people associate with emerald eyes comes from the clarity of the stroma. The fibers are arranged in a way that allows light to pass deeper into the iris and reflect back outward, lighting up the yellow pigment from within. can be compared to how light travels through a gemstone. Because there is very little brown melanin present to dull the color, the green appears pure and intense. This trait is recessive and depends on a very specific combination of genetic factors, which makes it one of the rarest confirmed eye color outcomes in humans. Now, let's break the pattern. We have covered blue-green, earthy green, and pure green. But what happens when an eye seems to shift and blend colors? That brings us to the hazel green variation. You might wonder whether hazel should even be grouped with green at all. On many medical forms, hazel is listed as its own separate category. However, when we focus on the mechanics of color, many hazel eyes are actually green eyes that contain a concentrated burst of melanin near the center. This feature is often called central heterochromia. Picture the structure of a solar eclipse, where a darker center is surrounded by a bright ring of light. That is similar to the layout of a hazel green eye. The outer portion of the iris shows a true green created by the same light scattering we have discussed. Closer to the pupil, however, there is a clear concentration of brown or golden melanin. We classify this as a green variant because, from a normal conversational distance, the overall impression usually appears green. What makes this type especially interesting is how dynamic it is. The pupil expands and contracts in response to light and emotion, which physically changes how much of the green outer ring versus the brown center is visible. In bright sunlight, when the pupil becomes smaller, the green ring is more noticeable and the eye looks brighter. In dim lighting, when the pupil widens, the brown center takes up more space and the green appears reduced. This shifting visibility leads many people with this eye color to say their eyes change depending on mood. In reality, it is simply the movement of the iris revealing or covering different pigment layers. Now let's move into a darker part of the spectrum with the forest or hunter green.